All right, class, as promised, let's continue with a couple more rational functions. And again, it's really not that complicated. We're bringing in the vertical asymptotes and the horizontal asymptotes you learned about, and the only new part is the derivative. So that's the one we need to worry about. So let's go through this one more time. That's what we have to do. As I said, factored form really helps if we can factor. Okay. So the top is an x plus 2, the bottom is an x plus 5, and an x minus 3. Okay, so where are the, let me write it here right away, vertical asymptotes. We're getting a vertical asymptote at any x value that makes the denominator 0, right? But not the top, which again, nothing reduces, so that's what's left. So in other words, I'm going to have a vertical asymptote at x equals to negative 5 and another one at x equals to 3. Okay. Horizontal asymptotes, the rule said look at the degrees. If the degree of the top, which is by the way a 1, is less than the degree of the bottom, then automatically y equals to 0 is a horizontal asymptote. Done. Okay. What else should I be looking for? Intercepts. In other words, it's going to help, and again, you can do that at the end where you make yourself a table of values for all the important parts. It doesn't matter now, like we did with the polynomials, right? So let's see, if I make x equal to 0, what's the y value that we get? And if we make y equals to 0, what's the x value that we get? So if we make x 0, all these parts are 0, I'm going to be left with negative 2 over 15. If we make y 0, remember, this is easy. When does the fraction ever equal to 0? The fraction can only be 0 if the top is 0, right? So when is the top 0? At negative 2. So this time we'll have both an x and a y-axis intercept. Great. Now let's get to the calculus part. And the calculus part is to make a sign diagram for the first derivative. Okay, well, let's find that first derivative. Okay, so the first derivative is going to equal to, being the quotient rule, I have to take the derivative of the top, which is, by the way, a 1, times the bottom, minus, leave the top alone, and take the derivative of the bottom. And the derivative of the bottom is a 2x plus 2. All over the bottom squared. Okay. So I'm going to distribute out the numerator. I can't leave it like that. It needs to be fixed because there's stuff to do with it. So that's an x squared plus 2x minus 15 minus, that's a 2x squared, 4x plus 2x, that's a negative 6x, and that's a positive 4 that's going to get subtracted. So there's quite a bit going on there. Now continue. So combining like terms, I'm going to get a negative x squared minus 4x and minus 19. All over the bottom squared. Okay, so this is the first derivative, right? Took a little bit of algebra, not that complicated in distributing and so on. Good. So what am I looking for with this derivative? With this derivative, I'm asking myself the questions, when is it equal to 0? So remember, one second, plug in my phone here. Okay. So where's the derivative equal to 0 and where is it undefined? Well, it's 0 if the top is 0, yes? And this one's not going to factor. I mean, we could factor out a negative if you want, or divide by a negative. And then you're going to have to use the quadratic formula to solve it. So that's a negative 4 plus or minus the square root of b squared, which is 16, minus 4 times 1 times 19, all over 2 times 1. I'm not even going to go any further on this. Why? What happens here in the radical, as you see? 16 minus 4 times 19 is whatever, 80, 76, something like that. The point is, the quantity inside here is always going to be, it's going to be negative. And if it's a negative radical, what do you get? Well, not a real answer. Okay. And remember, when it comes to a function, I'm only interested in what real x values make something happen. There's no real answers for this. So in other words, this is never going to have solutions, right? There's no real number that makes that 0. If anything, it's always negative. Okay. So, great. That's awesome. That means there's no critical numbers coming from here. This is never going to be 0. Okay. Could it be undefined? Sure. It's undefined wherever the bottom is 0, which is again, even if these factors have been squared, that's still an x plus 5 and an x minus 3. So the two solutions of the bottom are still negative 5 and positive 3. So that's what's going to go in our sign diagram. All right. So what I'm thinking right now is I didn't leave myself enough space for this problem. Okay, so anyhow, here are the x's. They go from negative infinity. The next one up is negative 5, 3, and positive infinity. And the first derivative is never 0, so there's not going to be a nice evening point anywhere there. But it's going to jump over things. The derivative is undefined at negative 5 and positive 3. Great. What are the signs? Let me see. I'm going to pick a 0 from in between here. The sign is going to be always the same, but let's just check here. So if I pick a 0 and I plug it into this derivative, what's going to happen? Just to show you. That's 0. I get a negative 19. I get a negative 15, but this negative 15 is being squared, so the top is a negative, the bottom's positive. By the way, the bottom's always positive, yes, because it's being squared. So this is going to be a negative value. Okay. Now, will the signs change left and right? The answer is no. Why? Because the derivative, or the top, was never equal to 0. So it's never changing sign. It's always the same. You're welcome to plug in any other value and see the top stays negative. Look, plug in a 4, right? The bottom's always positive because it's being squared, right? Negative 16, minus 16 more, minus 19, that's definitely a negative, yes? Put even a value here, negative 6, you will see that the top stays negative. It doesn't change signs. Why? Because it never got to go through 0 or equal to 0. Okay, so that's all negative. The easy thing is it tells me right away that what? My graph is going to go down, down, down. So how am I going to weave it through those asymptotes? Make it go down, pick it up, make it go down, and so on. So I ultimately do have the room for it. So where are my vertical asymptotes? I'm going to make them, I don't know, green, fine. So my vertical asymptotes are at negative 5, there you go, that's negative 5, and a positive 3, right? These are my vertical asymptotes. I have a horizontal asymptote, which is the x-axis. Y equals to 0, that's the x-axis, okay? And then I have a couple points. By the way, there were no new critical numbers that I would have had to put in my table of values. Most of the time it's the case. So the only two critical numbers were values that I cannot be plugged into the function itself either, right? I don't get a y value at negative 5 or at 3. The function's undefined. By the way, if a function is undefined at a value, its derivative is undefined at the value. Its derivative is undefined at the value. So what I'm saying is f of 3 doesn't exist. Neither will f prime of 3. Neither will f double prime of 3. So any other derivative further on is not going to exist. So remember, if a function is not continuous at a point, and it's not continuous because you have to jump over it, then it's not differentiable at that point either. Okay, so we discussed that. But I have a couple points I can hold on to. 0 and -2/5, and then -2 for x and 0 for y. Okay, so what do I know about this graph, and how do I weave it in these boxes right here? Okay, this is it. It says the graph goes down. So the graph comes alongside, again, this x-axis, right? It's his asymptote. So will the graph go up here or down here? Okay, if you said down here, you would be correct because it's going down, yes? So it has to decrease. So from up here, I can make it decrease because I would have had to make it cross, and we already know there are no other crossing points. And then the graph has to come down again. So which side of it do I pick up from here? Do I go this way or that way? Well, it has to come down. So it has to come down, down, down. It's crossing here in the middle, and then it's going down alongside this asymptote. And again, it has to keep coming down again. So it jumps, yes, comes down. It jumps, comes down, jumps, comes down. So it jumps and it comes down. And it doesn't cross anywhere else, right? These are the only two crossing points we found. They're usually right in the middle part. So there it is, easy. And that we knew how to weave it. How do I know it's up here or down here? How do I know it's up here or down here? We know because the derivative says it's going to be a decreasing function. Okay. All right, one more. So what's the first part? Try and factor it. So I'm going to factor this. Numbers to multiply to 2x are 2x and x. Numbers to multiply to 3 are 3 and 1. And I have to place them just so that I get a -5 in the middle, which I do. Numbers to multiply to x squared are x and x. Numbers to multiply to 6 and subtract to be 1 are 3 and 2. And then I need a -1 in the middle. So there you go, +2, -3 adds to -1 in the middle. So what do you notice? Ta-da! I have a common factor. So I was kind of promising you this earlier, but I have a common factor. So that reduces basically like we already went through in our 1.1 section. That simply means that this is your new and improved function that you're dealing with. That's gone. Except for what do you have to say? You have to say that what? X still better not equal to 3, right? If x is 3, I couldn't divide by 0 top and bottom. So 3 still has to be excluded out of the domain. -2 still has to be excluded out of the domain. So that's still the domain of the function. No 3 and no -2. So let's go up here and write the asymptotes. Where are the asymptotes? Well, I'm going to have a vertical asymptote at x equals to -2. That's it. Why only at x equals to -2? I'm not going to bring back the rules, but look back on your first page and it says you get a vertical asymptote at any x value that's only making the denominator 0 but not the numerator. For those values where both denominator and numerator are equal to 0, you get a hole in the graph. Okay, so look back on that first page. It says you have a hole. Anytime you can cross out a factor. Okay, is there a horizontal asymptote? Let's see, you're supposed to look at the degrees. So the degree of the top in this case is equal to the degree of the bottom. In that case, you take the leading coefficients and divide them. In other words, y equals to 2. Again, x squared goes into 2x squared twice. Even if you just look at this, x goes into 2x twice. So y equals to 2 is your horizontal asymptote. Good. Let's see about intercepts. This should be easy. If I make x 0, what's y? If I make y 0, what's x? If I make x 0, all of these are going to go, and I'm left with -3 over -6, which is positive 1/2. By the way, it's the same thing you get into your new and improved form of this function. Make x 0, you still get 1/2, right? It's the same thing. If you make y equals to 0, so this time, can this fraction equal to 0? Yes, if the top is 0. So 2x minus plus 1 is 0. If x is negative 1/2, that's what makes the top 0. So you got 2 points to hold on to. Okay, let's find that derivative. And this is my new and improved function. I don't need to get back to the beginning. It's all going to reduce back down to this anyhow. So when you find the derivative, this is your new function. Now we took care of it. The one thing that we know that is we're going to have to put a hole at x equals to 3. Other than that, this part's done. Okay, so let's take the derivative of this. Shouldn't be bad. The derivative of the top is 2 times the bottom minus, keep the top as it is, and take the derivative of the bottom, which is 1, all over the bottom squared. So you're going to get a 2x plus 4 minus 2x minus 2. Be sure to distribute correctly. In other words, keep them grouped and don't forget the minus sign. So, see, let's squish myself down here. I have the 2x's go away, and 4 minus 2 is a positive 2 over x plus 2 squared. Okay. So when I make the sign diagram for this first derivative, there's only going to be one critical number, and you're going to tell me why. Again, that's the only thing that makes this fraction anything to it. Yes, the fraction or this derivative will never equal to 0 because the top can never be 0. But it's undefined again if the bottom is 0. So that's your only critical number, and the derivative is undefined at it again. Now again, look at it. Do I even need to plug in values, or could you tell me what's going to be the sign of that first derivative? The top is 2. 2 is always a positive, right? The bottom's always squared. That's the nice thing, at least, about the quotient rule and using these derivatives, is the fact that the bottom always is squared, so the bottom's always a positive, yes? And then you just look at the top, right? Like this one here, the bottom's always a positive. The top is always a negative, right? We factored out this minus, and this thing never changes signs, so this is always going to be a negative something. So the top was always negative, the bottom's always positive. Okay, so in this case, both are positive only. Clearly, that means plus plus. Clearly, that means we're going to weave the graph by going up and up again. Okay, so let's graph this thing. We're ready. There's really not much. All I know is wherever those asymptotes are going to end up being, the graph is just simply going to go up and then up again. So where are the asymptotes? At x equals to -2 is my only vertical asymptote. And this time I have a horizontal asymptote at y equals to 2, not 3. So the other 3. So the graph is simply going to get weaved here, 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 or here, right? In these 4 quadrants, yes? Just like the 1 over x function. So where am I going to put them? Well, the fact, okay, let's put some points as well. What do I know? X equals to 0, y is 1/2. there's this point right here. And then x equals to -1/2, y equals to 0. Okay, so it's easy. We know the graph goes up. So as the graph comes along the horizontal asymptote, which side does it have to come? It has to come from up above because it has to go up. Yes. Then what else? It's gonna jump over the vertical asymptote, has to go up again. So because it has to go up again, it's coming from down here. It's also, these are good clues that it's not above because it has to cross through these points. And there's one more thing that we need to make sure we're doing. What is it? That when x is equal to 3, we leave a hole in the graph. So as this graph comes by and passes by 3, I'm going to leave a hole in the graph. And of course it keeps going. Shouldn't have made it come up so fast. And of course it keeps going under, right? It's staying under the horizontal asymptote. But as it passes by x equals to 3, I have to throw that point out of the domain. Okay, that's the hole. All right, this is it. This was your section 2.2. I decided to just break it up. At first, we're teaching the whole thing in 2.1, but that's just too much. We never finished this section. So we split it into two, deciding to put the rationals by themselves. All right, that's 2.2. That's a wrap.